Problem D. Survey in class. There are n students in the class and m topics that the teacher has asked to read about. Each student has read a range of topic, continuous range of topic, namely Li to Ri. Now that teacher will ask questions from topic, and if the student has read about that topic, his score will increase by 1, and if the student has not read about the topic, his score will decrease by 1. The teacher wants to maximize the difference between the maximum score achieved by the student and the minimum score achieved by the student. The key observations are, if we want to maximize uh, the difference between max score and min score, the teacher should only ask questions. Let's say Q is the set of questions that a teacher asks. This set should only contain the topics which are read by the student who will score the max score, and it should not contain any topics which was read by the minimum score student. Because if you ask a topic which is read by a minimum score student, there is a possibility that the maximum score student has not read the topic, and his score will drop, and minimum score student's score will increase, and the net difference will decrease. So we only ask the topics in the range of the maximum scored student and nothing from the range of the minimum score student. So let's see the brute force algorithm. We will iterate through all possible pairs of students and assume I is the maximum scored student, J is the minimum scored student. So this is the maximum scored students range, this is the minimum scored students range. We only ask the questions which he read which was not in the intersection. So his score will be, let's say the length is alpha, his score will be plus alpha, this guy's score will be minus alpha, and the difference will be plus alpha minus of minus alpha equal to 2 times alpha. Basically we take 2 times the length minus intersection, this portion multiplied by 2. Here we are brute forcing through all possible pairs, assuming I is the maximum score student and minimum. This will take O of n square, which is not feasible, that's why it's a brute force algorithm. Let's see how we can improve it by making few more observations. Let's look at all possible scenarios of how the maximum student and minimum students range will look like. Green is the maximum, blue is the minimum. Let's say they do not have any intersection, then answer will be 2 times the length of max student. And there may be a case that the minimum student overlaps in the left, and there may be a case that the minimum student overlaps in the right, and there may be a case that the minimum student completely lies within the maximum student's range. Now the greedy approach is that let's look at this case 3. There may be multiple ranges like this. If you want to find the minimum intersection towards right, we take the last pair Lij such that this Li is maximum. So basically we sort all the pairs Li Ri, let's say L1 R1 L2 R2. This is the given, we are storing the pairs as this. We sort A such that Li Ri is less than Lj Rj if Li is less than Lj. If we sort in this manner, The last element will be the furthest right. So we can find the intersection between these two, and that will be the minimum intersection in the right direction. For every element I, minimum intersection in the right can be from here. If this is completely outside the range of green, then it will look like this. We can repeat the same towards the left side as well, but here we will sort based on the ending range. Yes, then here we will sort for this case we will sort a in such a way that uh, rj is less than ra. Basically we will sort based on the ending value. So now we will consider the first element and compare it with the ith element. Find the intersection, subtract it, and take the 2 times the remaining element. Now there is one more case left. The minimum is within this maximum range. Now if the answer is such that the final answer is such that this is the scenario, then this green has to be the range. This rj minus lj minus plus 1, this is the length of the green range, right? Should be the max possible, max among all lj rj. Why this is? Because if it is not the maximum, let's say there is some other range whose length is greater than green's length of brown is greater than length of green, then we have this case that between the brown and blue there is no intersection, and the length of brown is greater than length of green. So answer will so when we calculate this as maximum and this as minimum, answer will be 2 times length of brown, which is greater than 2 times length of green minus intersection, because with green there is intersection, so it will further decrease. Also the length of brown is the greatest, so this cannot be the, but in our original assumption is that the final answer looks like this. The smallest score student is completely within the highest score student. If this happens, then the green should be the maximum uh, length range with maximum length. Otherwise the uh, otherwise the brown will have no intersection. If there exists an bigger range, let's call it brown, whose interval is bigger than green's interval, uh, it will have no intersection with blue, and its answer will be our assumption that green and blue form the final answer will be wrong. But you can argue that the bigger element, let's say brown is bigger, but there is some intersection, then what will happen? Then this will basically be scenario this scenario this scenario among these two scenarios that we already seen, and we would have already calculated the answer, and this would have not have been the final scenario where there is the maximum difference. Let's look at the code for this, not the code, like pseudocode. We are storing a as all the pairs. We are sorting a such that based on the li values, sorting it based on the first values. Now we are answer is basically 2 times the length of I minus intersection of I comma n. This is the ith element, this is the last element. Why we are taking last, missus? If there is some other element here, it will have more intersection than the last element will have the least right intersection. This is just some math to find the intersection. Basically min of Ri and Rn, that will give you this. Max of Li and Ln, which will give you this. If you take the difference, it will have this, the intersection. If this value is greater than that, the intersection will be 0. Basically, if Ln is greater than Ri, intersection will be 0. Length is basically Ri minus Li plus 1. We will repeat this again in the left side, but this time we will sort it based on the ending value, so that first element, this is the first element, this is ith element. First element will give the least left intersection with ith element. If there is some other element in between, it will have more intersection, because leftmost element will give the least left intersection. Finally, we find the index such that length of index, which is this, is maximum. After we find the index, we calculate the answer, assuming that is the maximum range and I is the minimum range, and we calculate the same formula, like 2 times length of index. Basically, we iterate through all other ranges which is not the index, and we calculate the intersection and subtract it from the index and multiply it by 2. This will cover all 4 scenarios. Basically, this is the fourth scenario, all 4 scenarios: left intersection, right intersection. If there is no intersection, it will come to actually one of these two. Actually, if the blue range is in the right, it will come in this value. The key observation is that here we just have to check for the scenario 4. We just have to check green is we can fix green as range with maximum length as in Lj minus Rj plus 1. Whichever index has this Lj minus Rj plus 1 as maximum, we can fix that as the green. We iterate all I as blue and calculate the maximum as answer. That's it.